9.1 is going to continue here when we move to division. The only thing that changes with division is that one step where you have to multiply by the reciprocal of the second fraction. So if I have a divided by b divided by c over d, the second fraction flips and we multiply. Same rules apply as the previous part of the lesson. Now, I recommend that if there's any factoring to be done, you flip first and then factor, because then you will eliminate wanting to cancel too early. So here's my division sign. So this is the fraction I need to flip. So I have 3x squared y over 20ab, and I'm going to flip, so I have 5a squared b cubed all over 6xy. So I took numerator, made it denominator, took denominator, made it numerator. Now I can go ahead and cancel 5 and 20, cancel, leaving 4, 1a and 2a, leaves 1a, 1b, 3b's, leaves 2b, 3 and 6 cancel, leaving 2, 1x and 2x, leaves 1x, and y become 1. What am I left with? I'm left with x ab squared all over 8. Because there are no variables in my denominator, there are no restrictions for this problem. So we are still dividing, so I'm going to go ahead and flip and then factor. Remember, these are all single numbers. So I have k minus 3 over k plus 1. Now I'm going to flip 1 minus k squared and k squared minus 4k plus 3. So again, numerator becomes denominator, denominator becomes numerator. Now I need to go ahead and factor. K minus 3 is already factored. This is the difference of perfect squares, so it factors into that. K plus 1 is already factored. This is a trial and error factor using the factors of 3 minus plus means that I'm going to have minus minus. Well, the only factors that work are those. Check your middle. Minus 3k minus 1k makes minus 4k. Go ahead. K plus 1 and 1 plus k are the same. Order doesn't matter in addition. K minus 3, k minus 3, cancel. Now, multiplication, things matter, but if I use my factor out a -1 trick, the numerator will become -1 times k minus 1 all over k minus 1. So those two factor and my whole answer becomes -1. That factoring out a -1 is a really nifty trick. Again, let's go ahead and multiply by the reciprocal. We will worry about factoring in our second step. So I've multiplied by the reciprocal. Now I have some factoring to do. X minus 3. X squared plus 9 is the difference of perfect squares. X plus 2 is factored. Now this trinomial, it's plus plus, so I know I have x plus and x plus, and I need to look at the factors of 6 so that when they combine they make 5. That means 2 and 3. Now I can go ahead and cancel x plus 3 and x plus 3. And that's it. So my simplified version is x minus 3, the quantity squared, or you can write it out like this, over x plus 2, the quantity squared. And my restrictions this time, remember we're thinking x plus 2 equals 0. What would make that happen? X cannot be -2. And so that is as simplified as that one gets. Now, fractions within fractions. I would say just go ahead and write these as side-by-sides. So like this one, I would write as m squared minus 9 divided by 8 divided by 3 minus m over 12. It becomes very clear at that point that you can flip the second fraction. Don't forget your parentheses. And continue your factoring as normal. So don't get thrown off if they look big and scary. Something like this one, you're going to want to go ahead and make common denominators in the numerator and in the denominator. So your numerator, if you have 1 over p plus 2, single number, divided by 3 over p minus 4, I'm going to multiply top and bottom here by p over p and p over p. So what I have is 1 plus 2p over p divided by 3 minus 4p over p. Now I can multiply by the reciprocal and have 1 plus 2p times p all over p times 3 minus 4p and cancel as I would normally. So let's go ahead and give this one a try. So I'm going to write it as a side-by-side first. Divided by, so this is my big bar, so top one divided by this one. And I think as soon as you write it as a side-by-side, it's far less intimidating because now I can clearly see where my numerator and denominators are, and I can write it like that. Now I can go ahead and factor. This is a difference of perfect squares. So I have x squared times 2y minus 3x, no factoring there, all over 3x plus 2y and 3x minus 2y times x cubed. Now, these two are almost the same, but I'm going to use that negative trick. X squared and x cubed cancel. If I factor out a negative in the numerator, I have negative 1 times 3x minus 2y. It just flips both signs, all over 3x plus 2y times 3x minus 2y. They cancel, and I'm left with negative 1 over 3x plus 2y. X cannot be 0 and y cannot be 0 because, oops. Well, don't worry about the restrictions on that one. That restriction is beyond what we are talking about. And that is the end of the lesson.